I'm going to be talking about the open source repository browser. I'm going to introduce myself first real quick. So I'm originally from Colombia, and I'm actually a mathematician who was turned into a software developer. I was working as a developer for Spider, the IDE for Python for a couple of years before I joined my PhD, and that's actually how I got involved into open source. And currently I worked with the Open Source Program Office at my university as a PhD candidate. My research is funded by the Open Source Program Office. Um, and since I joined Spider, I've actually been very involved with the Python community and like other open source communities. So you would see me helping organizing some conferences. I'm the security chair of the PyCon conference and the communications chair of the SciPy conference. And I also recently joined the program committee of the OpenSSF Community Day. And when I'm not volunteering for open source, I'm probably making music because I'm also a singer. And these are some places where you can find me. Please do reach out if you have questions, comments, or feedback, or if you just want to connect, that's fine too. So a little bit of background about this project. They started thanks to a Sloan Foundation grant that was given to the University of California system of OSPOs. So in 2024, we created this like OSPO system between 6 different universities of California. And the goal of this was basically to increase the like improve sustainability in open source academic projects and help with some of the like gaps and pain points of the open source within universities. And so my project is actually funded by this work, but today I'm going to be talking about what I'm doing as a PhD student. And some of this kind of intersects with the work of the OSPO network, but let's just say that today I'm talking about my research specifically, which is why I wanted to keep this kind of private because I haven't published some of this work yet. Um, so why an open source repository browser? This is basically a tool that maps and classifies open source project activity, specifically academic open source project activity. And the reason that this matters to me is to increase project visibility. There's a lot of work being done there that doesn't have the visibility outside from just like GitHub repositories to measure project impact. And I know that this is something that OSPOs care a lot about to showcase the impact of the open source projects at their universities for funding or just for support. Identify gaps for targeted OSPO support. So I know that there's been a lot of like OSPOs created recently within the university space. And I think that identifying which of the things like are helpful for them to do within universities is something that is a good outcome of this work. Improve open source practices, which in the end kind of it turns into sustainability, and improving security practices, which is actually the thing that I care the most about because that's what my research is about. But I'm not going to be talking that much about security today. Um, so what's on the menu for today? This is the recipe. Um, the main dish is actually talking about the repository browser database. So I'm going to be going through how I collected the data in GitHub, the classification. So basically determining whether some of these repositories are actually affiliated or not with the universities, and project type affiliation. What type of repositories do I find in within the academic institutions? And then some insights on open source activity within the UC California system. Then at the end, I'm going to give a demo, hopefully it doesn't break, for a small dashboard that I've been working on to show some of these like data. And spoiler alert, I did collect a lot of information from other universities that are part of the Curious system, not only the University of California system. So hopefully this would be interesting. And then at the end, I'm going to collect some feedback in the form of a short form, and we'll go through a Q&A, and hopefully it will be more like a discussion conversation where I can get some input from all of you. So for the data collection, what I did was basically building queries that contained some like keywords of all the universities, and I looked into different attributes in GitHub. So I did specifically 3 different types of searches. So searching for repositories, searching for users that are type of organization, and then users that are type user. And then depending on which of these like elements I was looking for, I picked some of the attributes. There's some limitations. But yeah, basically I built the queries. And using GitHub's API, I was able to gather the information that matched with this specific queries. Initially, I wrote some of this data in like a JSON file, but this started to get big enough that I decided to just build a database instead. Um, I collected extra information that I thought was going to be useful later for doing like a more deep analysis on the open source activity. So things like the community like documents that I think GitHub calls them, like the README, the code of conduct, contributing guide, security policy, issue and PR templates, other information about contributors, this specifically to get more signals on affiliation. So things like the bio or the email of the contributors of the repositories. And then also, if the repositories are owned by organizations, also some of these information of the organization specifically. I collected information on the commit history. So things like the author, the date for the commits. And this was specifically because I was interested in computing the bus factor for some of these repositories. So if you don't know what the bus factor is, it's basically a risk indicator that measures how many people within a project have to get run over by a bus for the project to like fail. So this is basically just a risk measurement. And then I also have been looking more into security metrics. So I've been using scorecards, which is a tool by the OpenSSF that measures different things within your repository in terms of like security metrics. And in the end, what I got was just a fairly big database, an SQL database specifically, with a bunch of tables and a bunch of repositories. After running this with the 10 universities of California, I was able to collect 236,000 repositories and about 6,000 organizations, which is it's great. However, there is a lot of limitations with GitHub's API. There is like API limits, so there is like a certain amount of data that you can get with each query. So this is in no way comprehensive. There is a lot more data there out that I don't really have, but this is a good start. The problem is that this data is just keyword matches. So the first thing that I needed to actually do was determine whether this data was affiliated with the university. And I'm going to convince you that this is a hard problem. There is a lot of false positives in the data that I collected. This is some examples of false positives. So for example, there's a lot of repositories that contain collection of computer science courses or collection of universities in the US that have XYZ program. And some of these will have in the READMEs listed all the universities, like, I don't know, in the US or like anywhere in the world with some of these things, right? So as you might imagine, University of California appears in a lot of these. So a lot of these keyword matches actually turn out repositories that are just compilation or aggregations of information. That's an example of the false positives that I got in my data. This is another very interesting example where the acronym for a specific university, like Santa Cruz, actually matches the acronym for other two universities, one in Spain and one in Shanghai, I think. Yeah, and this is a lot of the false positives that I got. It's like universities that have the same acronyms but are not really they're not really the university that we're talking about. So that's why I had to start thinking about how do I do a classification that will tell me whether these projects are affiliated or not with the university. I use 3 methods, but I'm actually going to talk about only one of them. I just want to convince you that I did not just say, let's do LLMs because that's what everyone's doing. I actually tried different things. The first thing was the score-based classifier, which I basically just intuitively gave some scores depending on which keywords match in which attributes. And then I just had like a base, like a score that would give me some affiliation. That was not very accurate because the context in which each keyword appears, it's very important, as I just show you. I also tried embeddings plus machine learning. So if you're not familiar with embeddings, what you do is basically you take a bunch of text and you turn it into a matrix using language model. And then with these matrix, you can use machine learning in order to predict affiliations in this case. I use very different machine learning approaches, but in the end, like support vector machines was the one that gave me the best accuracy. So I ended up kind of just using that one. Um, and then the last method that I used was LLMs, of course. This project started more than a year ago. So at that point, I think GPT 3.5 was probably the best model. It has changed a lot. So I do have results for 3.5, 4.0, and 5 mini. And basically, this is the one that I'm going to be talking about because it's the one that gave me the best results. I put this graph just to convince you that GPT-5 mini is by far the best in these particular scenario. There is a lot of trade-offs in terms of accuracy, time, and money, specifically with the score-based classifier that's like free and it doesn't require that much time, but it's not very accurate. If you're talking about embeddings and machine learning, because this is a supervised machine learning model, you do have to do some manual labeling, which requires a lot of time, but it's actually cheaper. And LLMs, of course, the trade-off is the money. I only use OpenAI models because I have credits with my university, but I haven't tried other models that might be cheaper or even free. So I'm not necessarily saying that LLMs are expensive, but they do require a cost in this case. And then so in this graph, what I actually basically did was I labeled manually some data, I think 100 data for each of these 3 universities that I just picked randomly. And then these results kind of have the comparison of the labels with the LLM versus the manual labels that I did. So for all of these 3 methods, it is necessarily to do some manual labeling if you want to actually get some like results accuracy. But if you want to do the supervised machine learning, you actually need other manual labels for training the data, which is not the best approach. So talking about LLMs, which is the method that I'm going to be discussing since it's the one that gave me the best accuracy. What I did was I took some of the metadata that I had collected for the repositories. So things like the name, the email, some of the kind of like general information that could give me signals of affiliation, plus the details about organization, plus details of the top 2 contributors for these repositories. And then one of the hardest things to do for this was actually coming up with a definition of affiliation. And this is something that I had to do kind of like trial and error, basically just trying different definitions, testing with some manual labeling and seeing how the LLM was performing with different definitions. This is something that I can definitely still improve, but this is the definition that I have for now. I identified like 7 different signals for affiliation. This is not actually the definition. The definition is much longer because for each of these different categories, I put some examples of signals so that the LLM can actually look for those in the repository. But basically, this kind of covers things like the contributors' emails match the domain of the university, or in the README, it says specifically that this is a project from like XYZ university, or for example, the license belongs to one university, or for example, it says that there is a collaboration between this university and this other university. So it's like basically different signals that could indicate that the project is actually affiliated with the university. And this is where the context actually matters. If there is a keyword match where it says something like, these are the list of universities that have computer science courses, then that's definitely not affiliated with the university. It's just a keyword match that it's random. But in this case, it's where we're like context matters. And that's why we're using LLMs in order to identify this. And then I basically just built a prompt where I pass the metadata of the repository, plus the definition of affiliation, plus the university information. So all the keywords that I had shown you before, the name, the acronym, the email, and the like alternative names. I pass all of this to an LLM and I ask the LLM to estimate a probability between 0 and 1 that represents how likely is that the repository belongs, well, it's affiliated to the university, and a brief explanation just for me to understand in some of these cases that it goes wrong, like why it goes wrong. By doing this, I was able to identify 47% of projects affiliated, so that's actually less than half, which is a lot of noise. I have to say, I did clean the data a little bit before running this, there's a lot of projects from the 236,000 that I collected from the 10 universities that are empty. They have like no lines of code. Some of them are archived, some of them are templates, some of them are forks, and they were probably like repeated. So I got rid of these four things before running this affiliation algorithm. And then after cleaning the data, I got 173,000 repositories, and then only around 81,000 of them were predicted to be affiliated. So again, this is 47% of this. So for the universities like UCSB, UCSC, and UCSD that I actually had manual labels that I was able to compare the affiliation with, I picked the best threshold. Like if you want to minimize false positives or maximize or minimize false negatives, depending on kind of what you want to do, you can pick a threshold. And then for the other ones, I just stick with 0.5 as a threshold. So anything that the LLM predicted as 0.5 or more, I said this is affiliated. But you can pick your threshold kind of depending on how strict do you want to be about false positives or yeah. The second thing that I did after predicting the affiliation was trying to get a sense of the project types. So what are the different projects that we can find in the academic open source? These are categories that I did not come up with myself. These are from previous works. I did have to refine the definitions a lot to make them kind of like more specific to the LLM. And I used other indicators apart from the ones that I had used for the affiliation. I think I put things like number of stars, number of forks, number of contributors. And I think because some of these popularity indicators can speak about which of these categories some of these projects are. So basically, I picked 5 categories: development, which is used for like tools, applications, or like research in general; education for specifically class projects, assignments, or even teaching materials. So this is from the side of the professors or the students. I had to kind of put these both of them in like the same category because it was kind of hard to separate them. Docs just used for like any other type of documents that are not education or documentation. Web for like any like project pages or documentation, and then data for data sets. This is not the definition that I use. This is just a very short like segments of each of these categories. The definition that I used was much larger because I had to put some signals for each of the categories. And also there are projects that have some ambiguity, like, oh, it's a website, but it's a website for a class. So what is this? So I had to make some of those clarifications in the definition. And then the procedure was exactly the same as before. I just wrote a prompt where I gave the information of the repository and the definitions of each of the categories. And I asked to give me one category and then an explanation of each of these categories. So with these, oh, I see that the total is wrong at the top, but yeah, it's actually 81,640 projects that I computed these predictions for, which are the ones that were predicted to be affiliated. So I only computed this for affiliated projects. And then this is a lot of information, but let's just take a look at some little things. The first one is most of the projects are between the category of deaf and education. They have like in total, they have like sort of the same percentages in the like total distribution of the universities. And if you can see, it's kind of similar, the percentages in all of the universities, like 47, 38, 44, 39. There's some discrepancies, but the biggest discrepancy is actually UCSF, which I see this as a sanity check because UCSF is a university that, in case you don't know, it only has graduate studies. They don't have undergrad programs, which means that most of the work there is focused on research. So this explains why, I mean, there's a lot of less classes, and this explains why the percentage of education materials is much less in comparison with the other universities. So this is interesting sanity check for me to see, oh, maybe these numbers actually do make sense. If you look at the other categories, there is very few in data or web or docs. And there's a certain amount of like repositories that did not fit into like any of these categories. So also interesting to look at those and see what they actually are. But yeah, this was basically the distribution of the project type um, computed by like LLMs. After looking at the project type distribution, I went and I looked at some insights. So I was interested in like language and license. I put the project type bar distribution just so you know, like in this little like bars, like what is the actual total, so you can see about how much percentage is that. So you see for this one, for example, most of the Python ones are deaf, and Python is actually the most common language, which actually agrees with the GitHub like latest report. And then Jupyter has most of the education category here, which also makes a lot of sense. In terms of license, MIT is the most popular one, followed by GPL and Apache. And but there's actually a lot of projects that don't have a license. It's not quite 77.5%. I said use this number with caution because I'm relying on GitHub's API, which means that if GitHub doesn't identify your project's license because you wrote it wrong or because it's not in the right place, then it's classified as none, but that doesn't mean your project doesn't have a license. However, there is a very large number of projects without a license. My guess is that it's still about around 70% or a little bit more. But a lot of these are like false negatives because the project could have a license and just GitHub's API wasn't able to identify it. But this is one of the most concerning things, I would say, from the things that we're looking at. And if we look a little bit deeper into the community practices, so I was talking about the community files that GitHub kind of encourages, we see that there is a lack in things like contributing guides, PR templates, code of conduct, security policies. There's less than 2% of all of these things in the projects. And there is some projects that even have more than 200 stars that don't even have some of these things. So this is definitely an interesting gap that I would say OSPOs could like get support with. This heat map shows that the increase in stars actually does improve some of these practices. The license, for example, is very like obvious. The projects with more than 200 stars, 90% of them actually do have a license. But then for the other practices, it's still, I mean, it increases a little bit, but it's still not very good. Only 6% of projects with more than 200 stars have a code of conduct. If you want to find more about this, and like, yeah, more specifics, I wrote a paper about this. This is the first version that was published last year in June. I released the last version 2 nights ago, but it hasn't been published, but it's just the version 2. So it should be the same link. It should update between today and tomorrow. And there's more specifics about like all of these processes and the graphs and more explanations. Now time for demo. So using this data plus extra data that I collected for the Korea's member universities, I built an interactive dashboard. The goal was to visualize some of these repository metadata. This is a work in progress, so it's a little bit unstable. It is very slow, and I'm definitely not a web developer or a designer, so it might not look as pretty. But hopefully we can all work together and make this more useful. So let me switch tabs. So this is the landing page of the dashboard. I just want to show maybe some of these things. This is in a GitHub repository if you want to like play around with it. Some of the links in the document that I shared have the repositories for this. But basically, this has an overview of some of the things that I already talked about, like the project type, the language distribution, the license distribution, and these community file presence. In this case, I have 31 universities. So there's the 10 universities of California, plus I think all of the Curious universities are actually here. I didn't collect all the data using the 3 methods that I talk about, but only some of them. And there is a prediction threshold 0.8 that is already applied here, just because I wanted to be more strict about false positives. And then there's information like the total number of repositories, the total number of contributors, the percentage with a license, that if we see we add other universities, this increases a little bit, which is interesting. And the average plus factor, which is very concerning to me. Something that I really wanted to do was to make this interactive so that you can explore data individually, depending on what you're interested about. So for example, if you filter here, University of California, San Francisco, this will update all of your numbers, all of your graphs to show you only University of California, San Francisco. You can apply filters by, for example, stars. So you care about the projects with like maybe more than, this slider is a little bit tricky because it's a lot of, yeah, it has a very high maximum. But for example, here, more than 292 stars, it will also show you the projects with more than 292 stars. It's loading. Again, it's slow. Yeah, okay, yay. 1,000 projects. The average plus factor increases a little bit, and then the repositories with license also increases a lot. So yeah, this is kind of the landing page. I'm hoping that this would be like an overview of some of the information for the universities. In this tab of universities, you can actually like see each of the universities. I'm going back to University of San Francisco because I like it. And then if you click one of these repositories, you can actually see some of the information of each repository. So you can see the name, the university, the license, some of the information that I already collected. And you can actually see the README and the contributing guide and the security policy rendered if you wanted to. This is one of the things that I care more about, impact. So I have some of the things that could potentially mean impact, but this is something that I definitely want to get your feedback on. How do you measure impact? Health. So talking about the presence of some of these community files that I was talking about. And no, it doesn't not only work with UC universities. This has the universities of the curious, yeah, of the like all the ones that are members of curious. So for example, I don't know, Trinity College of Dublin has some repositories here. George Washington University. Yeah, there's a couple. Oh, this filter is applied, so it's not showing us many. But yeah. So right now it contains data. It's not comprehensive, but it contains data from all of the universities for the curious. I got lost. Sorry. Yeah. So health. And the last step here was security, which a lot of them don't have these metrics yet, just because I haven't finished running most of the scorecards for a lot of the universities. But if they do have it, they will show the scores of each of the metrics that scorecards sees as important for security and a total score. This last step has some insights, but these are basically just the same plots that I had in my presentation, except that they are interactive. So you can see that they actually update when you apply XYZ filters. And I'm hoping to have like other tabs that will measure like kind of like the big picture in security and maybe some other like sustainability metrics. I also implemented a chatbot. I'm using ChatGPT though. Well, not ChatGPT, but like OpenAI. So I'm actually paying some credits for this. So if you want to test it, you would have to use your own like API keys. But basically, I thought this would be interesting to have a way to interact with this that was more like without the filters, but just kind of asking for things. So things that you can ask for is, for example, show me the top 20 repositories by stars. And these will actually filter by that specific query. It will filter all the tabs. So in this case, it's showing me that there's 9 universities at the University of Stanford that have more than 20 stars. You can also explore the repositories individually. And then also the Insights tab should get updated with only those universities. Maybe let's see this one, repositories with security policy and contributing guide. Should be interesting. Cool. So there is 97 repositories out of all of them that have both a contributing guide and a security policy. Maybe we can see, so we pick one of them, we can see the contributing guide and the security policy here. And yeah, I mean, this allows you to see some of the metadata, including the predictions on the type prediction, and the university um, in these particular tab.